So we're given f of x equals x over 1 minus x to the fourth, all right? We're asked to find the interval of convergence for this function. So first, I'd like to bring up that this function, representation as a series, is the following. Okay, so that would be our x to the n, right, which is just 1 plus x squared plus x to the third, and etc. Okay, so basically what we want to get it into is actually like the 1 over 1 minus u form, remember? So let's manipulate this a little bit. We'll work with it. So this actually equals x over 1 times 1 over 1 minus x to the fourth, right? So what we have here in the u spot is actually x to the fourth. So we could set u equal to x to the fourth. And then what we have is actually x times 1 over 1 minus u, which is equal to x times the following. We can put in the series form. So then we have u to the n, right? Remember that? So this is like x to the n, u to the n, same thing. And we'll just put in x to the fourth in this spot. So then we get x times the following, and then we have x to the fourth to the n. So then here the exponents multiply. So, and I'm also going to bring this inside, and we'll work with that as well. X to the 4n times x is just the same as the series from 0 to infinity, x to the 4n plus 1. Okay, so this is the series representation of our function. So now what we have to do to find that, this is like our a sub n, right? So now we're going to use the ratio test to determine our interval of convergence. So we have rho equals limit as n goes to infinity of a sub n plus 1. So for this one, it gets a little bit wishy-washy because we have putting in n plus 1 for the n spot, right? That's why I say the parentheses around the n plus 1 are pretty important because then you have to distribute the 4 and all of that. And down here we have x to the 4n plus 1, okay? Oh, whoa, I didn't write the 1. Okay, there we go. And now this is going to be limit as n goes to infinity of, and now we have an x to the 4n plus 4 plus 1, which is 5, over, sorry, there we go, 4x to the 4n plus 1, okay? And then we also have, well, I'll break it down in the next slide so we have more room. So we're going to have limit as n goes to infinity of x to the 4n times x to the fifth over x to the 4n times x to the 1, basically. And the x to the 4n's cancel. So we just get limit as n goes to infinity of x to the 5 minus 1, which is x to the 4. So rho, oh, sorry, this is going to be our rho, right? That goes over here. Equals x to the fourth. Right? Remember, this is just a constant in terms of the limit of n. So we could have just brought that out, and that would just be 1. So anyways, this is going to be our rho, and we have to force this to be less than 1 in order for the sequence to converge, right? So our x is actually just less than 1. The absolute value of x is less than 1. So that means that our interval is going to be -1 to 1. And these are rounded brackets, and if you were to try to plug them in to the power series, you would just get that they converge at both endpoints. Or that they diverge, sorry. I'm getting them mixed up. They diverge at the endpoints, so they stay rounded. And this is our interval here. You could also rewrite that as -1 is less than x is less than 1. There are different forms of writing your answer.